Hello students, welcome to our channel. Today I am going to discuss kinematics. आज हम लोग kinematics करेंगे. तो सबसे पहले हम लोग kinematics को define करेंगे. What is kinematics? Kinematics is the branch of physics in which we deal about the motion. We deal about the motion without investigating or without knowing the causing force behind it. For example, suppose I drop this pen. A force of gravity acted on it which pulled it down. But in the kinematics, we will be interested about its motion, not about the gravitational pull. हमें ग्रेविटेशनल पुल के बारे में नहीं पता करना है कि इस पे कितना फोर्स लगा जिसकी वजह से ये नीचे गिरा. हमें सिर्फ ये पता करना होगा कि एक पर्टिकुलर हाइट से ड्रॉप करने के बाद कितने टाइम में वो ग्राउंड को रीच करेगा, या फिर ग्राउंड पे रीच करते टाइम इसका वेलोसिटी कितना होगा. और एल्स की वी मे बी इंटरेस्टेड कि आफ्टर ड्रॉपिंग टू अ सर्टेन डेप्थ what will be the velocity attained by it, etc. So basically in this chapter we would study about the state of motion, that is displacement, velocity, acceleration, etc. Not the force, that which force caused this motion. So the motion, before we starting the kinematics, we first divide the motion. So the motion basically can be divided into two categories: motion along straight line and motion in a plane. Straight line motion means when objects move along a straight line. When an object move along a straight line, we call it a straight line motion, or also motion in one dimension. For example, an object moving straight, a bus moving straight on the road, a person running straight, all those are the example of motion in a straight line. So basically when an object moves along a single straight line, then that motion is known as straight line motion. And sometimes it is also possible that object moves in two dimension, that is moving in horizontal direction as well as vertical. Suppose I project a stone in the air, so it advances in the horizontal direction as well as move up also. So that is the two-dimensional motion or motion in a plane. So right now in this video I will discuss motion along a straight line motion. First we will discuss straight line motion. So let's start. Straight line motion or motion along straight line. Motion along the straight line. First we will discuss motion along straight line. Before starting we have to understand something, that how to deal with motion. How we can say that there is a question. First we have to think about a question, that how we will say that an object is in motion. So basically if an object changes its position with respect to time, then the object is said to be in motion. जैसे कि सपोज एक ऑब्जेक्ट यहाँ है t1 टाइम पे, और यहाँ पे चला जाएगा ये t2 टाइम पे, और यहाँ t3 टाइम पे. So we can see that the position is changing at t1, at t equals to t1 it was there, after a time sometime at time t2 it is here, and at a time t3 it is there. So the position is changing. We will say that the object is in motion. So the first thing is position. If we have to comment about the motion, first we have to determine the position of an object. So how we can define the position? Suppose for example if I ask you what is my position, then it is not going to make a sense to answer this question because it may be different. Suppose from back side of me, from the back side wall, it may be 1 or 2 meter, and from front side wall, it may be 3 or 4 meter. So from different position, if I measure my location, it will be different. So there is a question कि from which point I have to measure. Means there must be a reference point from which I can make the measurement, and that reference point is known as frame of reference. So first of all we have to understand the frame of reference. Frame of reference, the very basic to study this kinematics, or in fact in entire mechanics frame of reference is very important. So very first we will deal frame of reference. Frame of reference in abbreviated form, it is also FO, or frame of reference. So I'm going to erase. फ्रेम ऑफ रेफरेंस क्या है? It is a set of three coordinate system three coordinate system along with a clock, for the reference of space and time. It is a set of three coordinate system along with a clock for the reference of space and time. See, we can represent it like this. So better this is your x-axis, this is a y, and this is z, and there is clock for measurement of time. So this is my frame of reference. So this is my frame of reference. From this point I can take measurement. This is known as origin. Now the second thing, once the frame of reference is decided that okay, this is my frame of reference, from here I will measure the position. Suppose my object is located anywhere, I can join that object with this origin and can say that this is the position. Once the frame of reference is decided, next we have to decide its position. The second thing is position. Position of an object is the straight line distance from the origin of frame of reference. Position of an object is the straight line distance from the origin of frame of reference. For example, suppose this is my origin. This time you can see I am considering only one axis. Say this is my x axis. Why? Because I am right now dealing with motion along a straight line, one dimensional motion. So my object is moving along a straight line. So we need not to take the other axis. The only one axis can do the job. So suppose this is my origin and point object say P is located at here, and this distance is say x. So this is my position. So the position is equals to the position x is equals to x, small x. Some point about it. It is vector quantity. It is vector quantity. It is denoted by capital X, and third, its SI unit is meter. Its SI unit is meter. So this is about the position. Next, third is displacement. Displacement. The straight line distance, the straight line distance between two positions is known as is known as displacement. Very simple. Just we have to take the straight line distance between two positions. For example, suppose this is my origin and this is my straight line x-axis along which the object is moving. Say the object is located at this position at t is equals to t1, and let this position is x initial, and suppose it moves and reaches to a position here x final. Initially it is here at a position xi. You can name also. Let this name is p. Name of the point is q, and this is the point say r. So the displacement can be given as displacement is equals to x final minus x initial, just like this. So some point, it is also vector quantity, its SI unit is meter, and it is denoted by S. So this is the displacement. We can take we can take another example also, numerical example. Instead of putting this x, we will take some numbers. Suppose this is the origin and the object is located at suppose 2 meter. This is the 2 meter at initial time t initial, or you can say at t is equals to 0 second. Initially it is located at this point, and after suppose 2 second it is located at 1 meter in this side, minus 1 meter. This is your minus 1 meter at t is equals to 2 seconds. So now I have to find the displacement. What is the displacement in this case from t is equals to 0 second to t is equals to 2 second? Very simple. I have to do nothing. I have to just take the final position minus initial position. X final minus x initial. So the final position is minus 1. It is located at minus 1. Minus initial location is 2. So the displacement is minus 3. See, the displacement can take any sign. It may be positive or may be negative because it is a vector quantity. As you can see here, it is a vector quantity. So this sign just carry the sign. This sign just carry the direction. If it will come with plus sign, means it is in this direction, or if it is in minus sign, it is in this direction. So basically, in the straight line, there is two direction possible. one is in the plus x, one is in the minus x. So here plus minus signs serve the purpose of direction for the vector. So in this video, this much only up to this, and in the next we will introduce some more terminology: distance, speed, velocity, average velocity, and we'll do the some more numerical also. Thank you very much.